So I was saying that I wanted to remind you a bit about the schedule. So basically we are on the midpoint of the course. So today's lecture is going to be probably the last lecture on like C++ core language. So there's no such thing. So that's the name I came up with. The idea of these names is to split up the course in two parts. And actually I was postponing all the object-oriented programming techniques and classes and so on for the second part because of many reasons. One of the reasons is to try to convince you that C++ is much more than C with classes. Because if I start C++ just talking about classes, then probably you might have this feeling. So for now we have seen a lot of tools, a lot of functionality. Today we're going to see the last part, I care, that you learn, and there is no object-oriented programming involved so far. So the idea of this is that you get to know the core basics of the language that are not related with classes itself. And starting from this lesson and so on, we're probably going to move a bit faster. So as another reminder, so on previous editions of this particular course, the whole lectures ended by 29th of May. So if you want to compare again like other editions, so you should be comparing against the fact that all these lessons were ending in the fourth week of the semester. So I'm trying to speed up the concepts so you also have more time to learn chunk by chunk. So as a reminder, also, so if you haven't, it's a really good idea to catch up with your homeworks. So homework 4 is already out, and during this week I will release homework number 5. And also homework number 5, as homework number 3, is related to the final project. So the best you can do on these homeworks is it's going to be better for you, because if you remember, you only have like 4 weeks. So this is 1 month for the final project, and it's going to be painful if you wait for the last minute to do it. So the idea is that you start doing steps for your project during the semester, right? Okay, so today's lecture is going to be half of the lecture about like some more functionality of C++ itself, but I'm not going to go really deep. And then we will see an introduction on classes, and then you have some homework to do after this lesson. Okay, let's get started. So utilities. So this is something that usually not all developers of C++ are super aware of. So the C++ standard comes with an utility libraries that includes a variety of libraries that provide functionality ranging from bit counting to partial function application. So this means you can do a lot of stuff. And these libraries can be broadly divided into 2 groups. So the language support library and the general purpose library. So the language support library is basically the set of libraries that interact closely with the language. So this will provide classes and functions that interact closely with all the features of the language, like the types. For example, there is a type support library. As an example, there is size_t. There's also a dynamic memory management library, and we will discuss about this on when we see memory management. But shared pointer, unique pointer is all part of this dynamic memory management library. There's also error handling. There's initializer list. So for example, whenever you do vector and then you do curly braces, you're basically using this functionality from the library and much more, right? There's also some general purpose utilities, and this means basically that these are utilities that will add a layer of functionality on top of the language, so it's not intrinsically related to the language. Abort might be one example. So for example, date and time is a great example of utility libraries. So the timing is not part of the language, but there is libraries for doing this. So you don't need to go and search for third-party libraries. There is also, starting from C++ 17, optional, variant, and any. We will see some examples of these utilities. And there's also person tuples. So we have seen tuples a lot because I think they're great, and also they provide similar functionality as Python related code. So if you go to previous lecture and then you search for tuple, you will see some examples of this particular utility. And there is also one example on homework number 3, I guess, on how to use this tuple. There's also swap, forward, and move. So whenever we see move semantics, this is probably in 2 or 3 lectures, we will be using these utilities. Also hash, so we discussed about hash on previous lecture. It's also part of this library. And then there will be a formatting library that is basically FMT, but this is coming in the next release of the standard. So basically, there are a lot of tools you might want to use that already come with the language. So if you have already a compiler installed that supports C++ 17, for example, then you have all these utilities for free. So swap is the easiest example. So basically you have 2 variables, a and b. You can swap these variables, so no need to write a swap function. So if you ever want to do swap, just go and use this. Usually to use these utilities, you need to include the utility library. So include utility, and that's all. So there is new crazy examples. So we will just discuss briefly how to work with these utilities. And also my recommendation is whenever you feel like you have the need to do some utility or use some utility, so go and check it up on CPP reference on the library. Maybe there is already something for you there. So on this case, this is variant. So this is new on C++ 17. And then basically a variant is something that can be anything like between integer and float. So I create an object of this variant, and then b1 actually can be an integer or a float, but not the both. And then, for example, whenever I do this, so basically I'm assigning an integer value to this variant. So basically I'm saying this variant is going to be of integer type. And in order to access this element, then I will be using another utility function that is called stdget. And then I will ask for the integer part of the variant. And then I can access this element. Of course, if I want to access the float part of this variant, I will get an error. But there is an easy way to catch this error. So there is also examples on the CPP reference. And then for example, I have another variant that is going to be of type float. And in this case, I will initialize this variable with this number. And then I can also get the floating part of the variant using this syntax 1, because basically the 0 part is the integer part and the 1 part is a float. I can also put float there. And there is also, so these 3 examples, these 3 lines here has the same meaning. So let's use this. So basically this all is the same. So I can do b2 and then copy the integer value of b1 or the 0 value or just b1, because it's now we are talking about an integer, and I can also access the integer like of b2 like this. And then if you try to run this example, this is the output of the program. So that's basically variant. It will depend up to you like where and how you should use it, but it's just an example of what are the utilities of the C++ language. So usually maybe you want to create a new type, and then inside this type you want to have an integer and a float, and then you will have some Boolean variables to use any of these types, but maybe using just a variant is a better example. So this is something that Python programmers will like. So whenever you get used to the type safety of C++, like me, you have really hard times trying to use Python because you never know the types. And basically any is basically any type. So in this case, there will be some syntax involved as usual, so it's never as simple as the Python syntax. But if you have an any type, it can be any type, and in this case, whenever you do 1, you will have an integer inside this type. Of course, you cannot do, for example, cout and then a, because a itself is just a class of type any, so it's an object of the any class, so you need to cast it to integer, and that's why there is this function called anyCast. So the syntax is not super good, but at least there is something. Then you can put a double without doing any further step, and then you can access this double with the same cast function, and then you can use Boolean or any type you want. So basically any can hold an object of any type. That's why the name, right? Optional is something also cool. So this is usually something we can solve using like if and else, but optional, it's an optional value, right? So on this particular case, we have a string factory function. This is the function I'm talking about. And then depending on an input parameter, like its create, I can return a string or nothing. So basically, the idea of this is to return an empty object if there is, for example, if the create variable is false, and this saves me one if and else statement. For example, if I want to create this more in C++ is awesome, I just call this function and then I just say true, and then how I access the value of the optional value is just calling value. And also, for example, so this is a trivial example, but you can work like better examples. I can also do something like this, like value or. This basically means give me the value of the optional, but in case the optional hasn't been created, so I will put this value. So basically this means if the string is empty, then the string value will be a sad face that is down here. So this is like some utilities you might want to use while writing your program. Again, this will help you to express the intent of your code much better than if you just fill your program with if and else, if and else, if and else. So make sure you at least take into account the utilities of the language while you write programs. Tuple is a really widely used utility. Again, we have seen these examples on previous lecture, but I really like tuple, sort of say. One big chunk of advice is that with tuples, the types are going to be really verbose. So in this case, you will have a tuple that is basically a tuple of a double, a char, and a string. And then you can also use a new type and just call it student, and then, okay, this is a student. This way you can create objects of this tuple with a much better syntax. Like in this case, we are saying, I will create a student, and then this student has this GPA, this grade, and this is the name, for example. And I can also make tuples on the fly with make tuple. And here I can use structured binding to get the GPA, grade, and name of this particular tuple. As usual, the recommendation is that you write this code down on your computer and then you try it, and then make sure you try to understand all the steps involved. Chrono is another utility. So in this case, there are much better ways of doing benchmarking, but let's say that you want to benchmark a particular function. So you have this Fibonacci function, and then here you will have the start and the end of the function. And here is the function call, for example, Fibonacci, and the integer is 42. And then you can actually print how much time elapsed between these two steps. So this is a really naive way of doing benchmarking, but if you want to know how much time you spend on a function, this is a good way of doing it. Again, this is all part of the utility libraries. So ideally, you will go to this link and first, like, try to, I mean, it's not a book, so it's not something you can read, but you can check like what do you have in there for you. And so I have like bad news in terms of utilities. So we are using the C++ 17 standard, but if it happens that you go and work for a company in, let's say, 1 year, it's very unlikely that the company is using modern compilers. So there are many reasons of why this happens. One is that it's really slow for companies to do migration. So so if you have like products that are working worldwide, you cannot just change the compiler like for every release. That is like every 1 or 2 months. So as a alert and a warning, I want to warn you that in our courses we have the freedom to choose the standard, but so keep in mind that if you enter the industry like in 1 year, it's very unlikely that you will have all these utilities at your hand, unless on the company you work they are using modern compilers. But most of the utilities, like the good ones, came with C++ 14 and 17. So if you're using like something like C++ 11, that is already a 10 years old standard, then you will probably not have much of this. So I will skip this part now, so we can basically get to the meaty part of the lecture. But basically here you can see how to do error handling using C++. So I'm sorry, we need to skip this. But basically the intuition behind error handling using try-catch blocks is that you only use this for exceptional behavior. So I saw a bunch of submissions for homework number 2 that were using try-catch. So it's not really wrong, but actually an exception is something that it's an exceptional behavior. So if, for example, a wrong parameter should not lead to an exception. Make sure you go and check it out, this part of the lecture. There's also, I can also give you the link for Igor's explanation on this in case you want it. But basically, so it's often misused because people tend to do try-catch everywhere. And of course, this makes your code impossible to read. And then it's not the idea of this try-catch for error handling. So only use try-catch if you really need to handle an exceptional behavior. So if the input parameter is not correct, then you can print an error message of whatever. That's not exceptional. So it's something that might happen. So ideally, you should never use exceptions unless you're writing libraries or doing like some really robust library. So in our course, it's really unlikely that you need exceptions, but if you want to use it, go ahead. So I don't complain. But Google people just say, okay, don't use it. It's going to be a mess. Then the last part of this half of the lesson will be like about the input-output library. As usual, CPP reference has all the information for this, and then we're going to see how to work with files. But why I am putting this here is because it's the last part of the core language without talking about classes and memory management, and also because you need to use it for your homework. So how we read and write files. So we have been doing this for the cout, cerror, and cin. So basically the syntax will be exactly the same with the Angular brackets, but the difference is instead of redirecting streams to the standard output, that is basically a file in Linux, but never mind, we can do this right into files. So if you take as an example the homework number 3, then what we're doing, we are trying to create an image browser using HTML language, and we are throwing all the information to the standard output and then redirecting to a file. Of course, this is a really bad idea, and it's really prone to errors. It's very likely that this might fail in the future. For now, do it like this because that's the homework using the standard output, because by the time of homework number 3, we haven't seen this read and write of files. But of course, ideally, you will want to write the output of your functions to a file that is called index.html, not to the standard output and then redirect into this file. So basically, you have like a whole library that is, you get it by including this fstream library on the standard template library. And there's also some modes we will see, but there are like 3 examples here. So in this case is file in, so we will read a file, so this will create an input file stream, and also the counterpart is the output file. So with this file stream we can output streams to the file, and of course there is an input-output file that is rarely used, but you can also do it like this using fstream. So basically, if you want to read a file, then you will use input file stream, and if you want to write to a file, then you will use a standard output file stream. So how will you do this? Oh, sorry. So these are like the modes you can open. So when you create these objects, so in this case, for example, we are creating an object of, so we are creating an output file stream, and then you need to use some parameters. The first one will be the file name, of course, and then the mode. And then the mode can be any of these or any combination. So you can do append, you can do binary mode, you can do in, out. So there are many modes of how you can deal with files. As a really modest example, so let's say you are working with ASCII files, then it's really easy to use these output file streams, actually using the same syntax as string streams. So remember lecture 1 or 2, I think 2, when you have structured formatted data, you can use this streams syntax really easily. So you can say from this stream, like put it on an integer. So in this case, we have, let's use this color. So we have an integer and then a floating value and then a string and then another floating point value. So with this particular structured format, it's really easy to use file streams because the syntax is quite nice, let's say. The only problem is that the same way of string streams, it will fail if you have, so if the format is not correct. So keep in mind that if your file have some errors, then you will need to deal with this error or use another approach, like we will see now. So this is the example we were talking about. So again, you can create this file and try it at home. But basically the syntax is quite easy. So the first thing you will do is you will create this standard input file stream. Then you need to provide the file name you want to read, and then the mode. In this case, you only want to read. So you will use the iOS base in. And then how you read data, you basically output this input file stream and then to the structured data form. So we have I, A, S, and B, not the best names, but it doesn't fit on the slide. So I is basically an integer, the A is a double, and then S is a string, and then the B again is another double. So so this is the file we're talking about. So probably having the file there would be better. But again, so we have one integer, floating point, string, and floating point. Oops. And then here we have the same. So this way you can read files really, really easily. And the syntax is like going, so passing the string through all these variables. If you have any error, then this while loop will fail. Otherwise, it will read all these lines until it reaches the end of the file. So this is a way you can use to read files. But let's say that you don't have the format, or it's not really structured, like you don't always have the same lines. So you will do it like using the getLine function. So this is, for example, another file you want to read, and this is a source code on how to read this file. So basically you will get this line and populate a string. Ideally, you can try this example at home. How we write text files using this output file stream is basically the same syntax as the input file stream, but using the other mode and the other object that is the OF string. So here we create a file stream, and this is the file name. It's going to be out.txt. And in this case, by default, we don't specify the mode, but it's going to be basically to write. In this case, we want to just write one double. The only problem with this is that we are writing an ASCII value, so this will be a string. So we need to specify the precision of this double. And of course, we will lose some precision if we want to write floating point values to string format, that is basically this ASCII. Again, if you pay attention, the syntax is exactly the same as cout. So in this case, the output file stream is acting as the cout, and this is what you will do if you were doing this image browser exercise, but in a good way. But remember, just use the standard output for the homework. And then lastly, about reading and writing files. So we have seen quickly two examples how to read a text file and how to write text file or ASCII format, but there is also a better way of doing this that is called serialization, where basically we will try to put all the binary information from our data into a file, and this is also called binary file. And there are many ways, many reasons why you want to do this. So instead of writing like ASCII data, like for example 1.56 whatever, we will write the sequence of bytes that represent this data. So the document must have a structure, because if you open the document, you will see zeros and ones. So basically you will see binary information, so it's nothing you can read. So you really need to know the structure of your document. Naturally, the writing and reading of this type of files will be really fast, because that's basically, so you need to convert to any intermediate representation. So if you have like 1 byte that is 8 bits and you want to write it to the file, you just need to put those 8 bits in the file, and you need to represent this particular byte with a character or whatever. There will be no precision loss for floating points, because we are going to put, for a floating points, for example, the 4 bytes that represent the floating point will be directly written to the file, so there is no conversion to 1 dot whatever, and then it will be actually quite smaller than just ASCII file. And why is this? Because the binary data is much lightweight, so it's basically zeros and one. And if we want to represent a double with a string, then we need, for example, for a precision of 20, we will need 21 characters. So 21 characters is 20 times 8, so it's a lot of bytes for representing just one double. So they will be much smaller. The syntax is going to be a bit ugly, but we will discuss it a bit right now. So let's say I have, for example, an image, right? Like an image that has like really small one. We have 2 rows and 2 columns, and then basically this vec will represent the data, and in this case it's going to be full of zeros because it's basically a dummy image. So how I do this, how I write this image into a binary format, then the first thing again is to open an output file stream, and then I will pick the name. In this case will be image.dat, be image.bin. It's up to you. The name is not relevant. And then I will pick 2 modes. So the first mode is going to be out. So I want to write this file, and also I want to do it in a binary form. And then instead of using the OStream operators, as we saw with the structured data and ASCII format, like with the angular brackets, we need to use this sort of ugly syntax. So there is no remedy for this. But basically so let's say the first thing we want to do is to write the rows and the columns. And this is part of the structure of the document. So this amount of data will be a row, and then it's basically an integer, and then it will be a column. And all these binary digits will be all stick together on the file. And of course, we will run the example, and we cannot see the data. So how we do this, we will call this member function of the output file stream that is called write. And then we will use this ugly syntax that you will most likely understand in 2 or 3 weeks. But basically this reinterpreter cast will get the information of the integer value and will basically return the bits. So if you have, it's like open a debugger and you have like an integer value that is 4. So if you inspect the memory, you will have actually 4 bytes. That is 4, yeah, it's 4 bytes for integer. That is basically 32 bits of information. So this basically is converting from an integer format to a binary format. And then we need to specify the size of this particular element. So we know, okay, I will start writing. So you need to specify where is the element and then where this ends. So I can get this amount of digits, basically zeros and one, and put it into the file. And then the same holds true for the vector. The only difference is that it's a vector, so the data is a bit longer. So first we will specify the first element, because this is where the vector will start, and then we need to write all the binary digits that represents this particular vector. And for doing this, we will use the size of the vector and then the size of float. Why float? Because the vector is holding floating point values. So a floating point value will have 4 bytes, and then the size of the whole vector will be the amount of members you have. In this case, 2 times 3 is 6, as far as I know. And then 6 times 4 bytes is going to give you the size of the chunk you want to write. So one thing I want to show you really quickly. So this thing. Yes, so for example, if we out demo bin, so this is basically the example we are seeing on the slides. So do time constraint, let's compile it and then run it. So if we, out demo bin. So if I run this example, then I will create this image.date. That is basically the binary form. And the first thing you can do is like try to inspect the file. Actually, let's do one thing. Let's remove this image so you know it is not there, and then we run the program and then the image is there. So if you want to inspect this file, this is what you get. So it's all binary data. So it's the same if you want to inspect the binary executable, so it makes no sense. It's basically chunk. You cannot get sense of the binary form. But something important is that this file is 32 bytes. So this is the amount of files of the file, and it's 32 because if we cut, so it's going to be 4 bytes plus 4 bytes, so we have 8, and then 6. So this is 6 times 4, it's going to be 24. So 24 plus 8 is going to be 32 bytes. So the binary form will store exactly the amount of data you have in memory. And if you want to try this, let me see, out demo, out sample. Okay, I forgot to do but if you do this with characters, then of course you know it's not going to be 32 bytes, it's going to be much larger. So how to read from binary files? The syntax is ugly and it's actually the same. You will provide an address to the variable you want to populate with the binary data. This is an example. My recommendation is you try both examples at home, and actually you try to do both. So you try to write this dummy image on a text form, so an ASCII, using the angular bracket syntax and the string operators, and also you do it in binary form, and then you compare the sizes and blah blah blah. So that's actually a really good exercise. So it's actually super easy to work with this, but the thing is, syntax, it's a bit ugly. So that's the only drawback. So the pros of using binary files is that they are faster than ASCII format, both reading and writing. The size is drastically smaller. So as you saw, if you have 32 bytes, then the binary representation on a file is 32 bytes and nothing more. So unless you do some sort of compression, you cannot go lower than this value. Another pro is that there are many libraries to facilitate serialization. So Boost serialization is a really good library and it's widely used everywhere. So you don't actually really need to write all these small functions calls by hand. You can use a library on top and make it much easier. And some cons is that the syntax is a bit ugly, but this is basically true for most of C++ code. Then the file is not readable by human. So this means that if you are debugging, for example, and then you want to inspect what you have written to the file, then you cannot make sense because it's just binary. Then also you need to know the format before reading. So let's say you write this image to a binary file and then you want to read it. You need to know exactly the format. So first you need to read an integer, then another integer, and then the vector. You cannot do like the other way around, because you will read data, but it's going to be junk, because it's going to be, so the file has no structure. It's like a stream of 1 and 0s. So you, the reader, need to exactly know how is the structure of this file. And then the last but not least, another con is you need to use this for your homework. So homework number 5 will be all about writing and reading to binary files. So basically you will be computing CIF descriptors, and then you will save this descriptor as binary format, and this is used for your final project. And then lastly, the file system library. Again, this is something that it came with C++ 17. So if you are working for a company, it's very unlikely that you will be able to use this, but there are another workarounds for using this. So the ideas of this library is that now that you know how to read and write to files, you also might want to perform operations on paths, on regular files, and directories. So for example, you want to create a directory, ask if certain file is created or not, and if there is no file there, then you can create your binary file, for example. So it's like a utility library on top of the input-output library to help you to work with files in your system. So it's inspired basically in Boost file system, as many of the standard libraries were incubated in Boost, make your life much easier. And again, all information is on CPP reference. We will see some examples on how this is important. So forget for a moment that you like how to create or read files. And in this case, we want to basically use the language as a shell. So on this particular example, I want to print all the files that are in a particular directory. So the first thing I will do with this example is to create a directory. So this basically is the same as doing make dir -p sandbox /a and b. And then I will create 2 file streams. So basically 2 files. One is called file1.txt, and 2 will be basically empty, just a dummy file. And then I will use this directory iterator. So this is really cool because you actually can iterate through the directory. And then you can do with this syntax, so this will be a path, and then call the directory iterator for this sandbox directory, and then you just print all the paths you find on this directory. So in this case, we found A, that is basically this, file 1 and file 2. So these are all the files you can find inside this directory. And B is not here because B is basically a directory, and there is no parent. So there is some explanation of why it's not being popped out into the output. But for now, the idea is that you can iterate through the directory. So if you're reading PNG files, this is something you can do. You can iterate through the data image directory and then get all the PNG files, for example. Then there's also utilities for file names. This example, again, I recommend you to try it at home, but basically, so using the path object from the file system library, you can, for example, ask for the file name of this particular file, no matter where it is file. The name is bar.txt. So for example, for homework number 3, that is the one from the image browser, this is something you can do because you will have the image on the data, and then you only want the file name. So there is a question that isn't this in experimental file system? The answer is yes and no. Actually, it's a really good question. So the premise that if you need to do this, it's because you didn't install the LLVM toolchain properly. So the file system library is quite new. So it has been here since C++ 17. And for example, if you're using the default compilers that comes with Ubuntu 18.04, then it's not on file system, it's on experimental file system. Because 4 years ago, this library was on the experimental section, but now it's already stable. So actually, this is a good, really good point to know if you have if your setup is working properly. So if you cannot compile this example, then this means that the setup is kind of wrong, and I can help you. So we can discuss it offline on Discord. But actually, when I did the example, the first tutorial, when we did like how to set up the dev box, so just running a hello world is not really smart. because any C++ compiler can compile hello world. So maybe for future editions I need to compile a file system hello world, and this way you make sure that you have the compiling style installed and it's a modern one. I will help you offline. It's very likely that there is a really small error, but this is, I mean, if you're struggling with file system, then it's a matter of how you install it, the toolchain. More examples here on file names and also on extensions. So maybe you want to know, for example, you want to use the directory iterator through a directory, and then you have PNG files, TXT file, and whatever files. And then with this, you can actually ask for the extension for all these files. And if, for example, the extension is equal to PNG, let's do something. So this is really cool utility libraries that you can use to work with files on C++. More examples in here. Also, you can take the stem out of the file. So if this is the path to your files, then the file name will be bar.txt, and then the stem will be bar. So if you ask for the stem, then you will get bar. So this is really, really useful while working with file system. And also you can do exist. So let's pretend that you want to see if any files exist. So there's another demo here that basically you can ask. So there is a small utility function, and then you do file system exist, and then you ask for the path, and then if it's true, then you will print exist, and then if not, you will print doesn't exist. In this case, we are trying to see if this exists, or if this other one exists, and here is the output. So it's really simple. The idea of this example is that if examples are on the slides, then you will probably read it, and then you should try it at home. All these utility libraries are meant to make your life easier. So good luck with doing this with plain C or just doing everything by hand. And also, if you read like the file system API, like this file system exists, it's really English, right? If you don't know the file system library and then you see this syntax like file system exists, then you can guess that you are asking if a particular path in the file system exists. Then it's really easy to use. Okay. Sorry for the delay. So we reach one of the most important moments on C++. So I will say that if you have any question, you can ask it now. It's probably going to be a good moment for asking question. I'm sorry I had to rush to connectivity issues. Anyway, so who are we? We are C++ programmer, and we always want more types. So this is going to be a really high-level introduction on classes and the type system of C++. So basically, this is not going to make it into homework number 5, so don't be scared. But the idea is that you start getting the sense and the intuition behind why we want to use types. Like not the built-in types, but the ones we write. And also, just like the bad news is that this course is not about object-oriented programming. So usually, if you really want to learn this particular topic, you will need a full semester on just object-oriented programming. And then we will use some of the techniques because that's part of the core C++ ideas. But then the bad news is that I won't be able to explain you all the concepts on object-oriented programming. So it's really, really good if you know something from Java or Python, because we are not going to dive deep into the concepts, but how to use these concepts with this language. So C++ and classes are basically a big thing. So when C++ came into the game 40 years ago, by that time was C with classes, but now it's a much different language. It's much more robust and general. So types are indeed important. So there is one example here that I actually took this example for Björn, the creator of the language. There is this little guy that is called the Mars Climate Orbiter. And actually, so by 1999, And believe me, there's plenty of these cases on the history of science. So the NASA sent this guy to the orbit to Mars, and then when he was about to reach its orbit, something happened, and we never saw this guy again. So the little poor Mars orbiter was lost in space. And there are two drawbacks of this. One is that we are throwing junk into space, and this is really a bad idea. And the other drawback is that a lot of really bad stuff happened on NASA. So a lot of promotion didn't happen. Some PhD students didn't get the PhD just because they lost billions of dollars with this robot. So this orbiter were about to reach the orbit, and what happened by that time is that two functions or two interfaces were interaction to each other, and one sent a double to the other one. So a double is just a built-in type, right? So it's 8 bytes, it can be any floating point value with no extra meaning. But the problem of these two interfaces is that one was expecting to work with the metric system and the other one with imperial system. So when one sent the variable to the other one, it scaled this value by exactly 4.65. So why did this happen? Because there were no types in there. So it was basically a double. Double can be any kind of, can have any unit, right? So there were no meaning on the types, and that's why we lost this poor guy. So types are indeed important, and this is the motivation behind the type safety system of C++. So this is a bad example. For example, let's say we want to blink LED, and then we have this function that is called blink LED, and then I put it bad, so you know this is the bad example, the bad guy. And then we say time to blink. And then my question is like, okay, what are the units of time to blink? It's just an integer value. It can be 100, 1000. So if it's in milliseconds, maybe I want 100 milliseconds, but if it is in seconds, I need to do 0.1. So it's really hard to tell what is the unit of this value. When I will detect the error. So this is really important. This is the type of question as a C++ programmer you need to start asking yourself. It's like when I will face the error. So is this something that I will deal with at compile time or at runtime? Because if it is at compile time, then it's pretty good because I can fix it before I ship the little guy to Mars. But if it's a runtime, then I am not sure when I will face this error, because it's something that will happen at runtime. So all the type safety ideas of C++ are meant to happen at compile time, and that's why it's also a really safe language. What is a good counterpart of this example? Then write the same function, but instead of using integer, use milliseconds. Milliseconds can be anything. So on the utility libraries, there is this type already defined, but let's pretend that it's not there. Then you can define this type by your own. And then first, when you read the function, you see that you need to pass milliseconds, and second, you have two options. So in this case, if you don't specify the units, then you will have an error, and this will be a compile time error. So you won't be able to ship the robot to Mars unless you solve this compilation error, and this is really good news for you. And then if you use, for example, seconds, that is not milliseconds, as specified on the syntax, the type safety system of C++ will abort compilation and also will give you an error at compile time. Again, this is really, really good and makes C++ a really type safety language, and all these kind of errors can be detected at compile time. So this is before shipping any program into the real world. So this is what we really want to do with types. And let's pretend there is another example. Go and check it out. If you want more flexibility, you can also write this same function, but use multiple types like seconds and milliseconds. And also when you use the interface, so when you call this function here, it's clear that you want to do 2 seconds and then 150 milliseconds. Again, if you don't specify the type, then you will get an error. Compile time, you're safe. Like type safety in our field, like just an example. So ROS1, so actually people from ROS is doing a lot of work to migrate from ROS 1. So when ROS 1 started to be a code base for robotics, this was, I guess, before C++ 11. There was not much expertise on the language itself within the people. And also, I mean, probably the tools were not there. So ROS 1 has a lot of drawbacks, not only with type safety, but this is one example. So if you go to the Hello World example from ROS, from ROS 1, you will see, actually the link is here on the description, so go and check it out. You will see this toggle node that will just print to the standard output, and then at some point you will see this statement that basically says loop rate and then 10. And then the question is like 10 what? 10 hertz, 10 milliseconds? What is this loop rate? From people who know ROS 1, you know that this unit is in hertz, but what happens if you don't know this? If you put 100, it will also work. If you put 1,000, it will also work. So there's no guarantee on the units and on the type of this particular value. It's just a number, an integer number with nothing, with no real abstract information built on top of it. As a good example, now ROS is moving to a better C++ usage. And for example, the same Hello World example, now it's using milliseconds. So you will create a wall timer. So the syntax is a bit different because the ROS changed itself. But now instead of doing 10, they are using 100 milliseconds. So you know it's 10 hertz and the period of the timer is going to be 100 milliseconds. For sure, you know this, it's at compile time, it's guaranteed to be this, no problem, you can be safe, you can sleep this night knowing that your timer will be working at 100 milliseconds of period. So this is really, really good usage of the language. So it's the same functionality as the previous example, but much better code, better readability, and safer. And it's also guaranteed to run every 100 milliseconds. Right? So this is one of the many motivations behind classes and the type system. So just to confuse you a bit more, I will be using the word class and the word type indistinctly. So whenever I say type, I can be talking about the class, or whenever I say class, I can also be talking about types. So classes and types are exactly the same in C++, and I like much better idea of types because when you do classes, people automatically think in object-oriented programming, and actually you can create types that are not meant to use with object-oriented programming. So the idea of types is much broad, and it's better for me to think it as the language to create new types instead of classes. So if you go to the book, you will see that C++ classes are just tools for creating new types that can be used conveniently as the built-in types. In addition, derived classes and templates allow the programmer to express, and this is really important idea, relationships among classes and to take advantage of such relationships. Ideally, the program that expresses these relationships closer to the real world will be easier to read and easier to maintain. A type or a class is a concrete representation of a concept, an idea, a notion, whatever. For example, a class can be a banana, can be a fruit, can be an image, can be a point cloud, can be whatever. A program that provides types that closely match the concepts of the application tends to be easier to understand, easier to reason, and easier to modify. So that's one of the key concepts of C++. So creating new types will allow you to write better programs, maintain this better, and make it run faster. So if you have an image type, you can use this type on your program, and then when I read your program, I will know that you're working with images. If instead of using image types, you use just an array, like this is how you do it in C, so you have an array, then if I see an array of integer values, I don't know if this is an image, an array of whatever. So it's much better to use types than just plain types. A class is an user-defined type, so floating point values are not user-defined types. Image, for example, is an user-defined type. This will consist of a set of members. The most common kinds are data members and member functions. So all the syntax on classes will be taught in next lesson. So As a reminder, I want to give you like a quick overview of the main ideas behind the concepts. And then the member functions can define the meaning of the initialization. This means whenever you create an object of this class and copy, moving this object and clean up, that this basically means destruction. And then the member can be accessed using dot, but this is basically the syntax. Also, something really cool is that operators such as plus operator can be defined for a class. So let's say, for example, you have a point cloud. So a point cloud basically consists of a set of x and y set points, right? And then you have another point cloud. And then you want to merge these point clouds together. Then one thing you can do is to define a point cloud class. This means a point cloud type. And then define the operator for this particular type. And then when you do, for example, point cloud 3 equals to point cloud 1 plus point cloud 2, then you will get the merge operation. And the meaning of this will be provided by you, the programmer. So it's not magically happen. You will, for example, do, okay, merging these two point clouds, just doing the plus operator means to append all the points from one of the lists to the other one. I don't know. So this is actually depends up to you, and it's up to the designer. But this will give you really good usage of the language, because if you see like this plus operator, it's much easier to understand, rather than if you call a function saying function that merge point clouds, and then you pass the two parameters, and then this will return you a third point cloud. This is basically much better to express with plus operator, and then we will see this exactly on next lecture. A class is a namespace, so as usual, whenever you create new entities on C++, you will create a new namespace. So it has all the same information, and meaning that a function namespace or an empty namespace. The public members provide the class interface to the outside world in the program, and the private members provide implementation details that shouldn't be shared with other parts of the program. And a struct is a class where all members are public. Much more details on next lecture, so don't really worry about this. So because we're doing computer vision, the most trivial example will be image. So this is how you will define an image class. Much of the implementation of this class is not there because it doesn't fit on the slide. But basically you will create an image class, and then you will have the public members and the private members. So in this case, we will have rows and columns, and then we are initializing this with 0, and this is what is new in C++ 11. And also with this, we are providing a way of create images that is not implemented here. So this is the same as defining a function, and then you need to implement the function. And let's pretend that there is a draw function that will draw this image on the screen. So basically, there will be an implementation that might be on image.cpp. We will see how to do this on next class. But basically, this is how you create an image. So you create a new image. The name is the same as naming any other variable. And then the type is going to be image. And then if you inspect the constructor, you need to provide the file name. So you say, okay, my file is in some image.pngm. And then I want to draw this function, this image to the screen. Okay, so some examples on types or classes in our field. So for example, will be something like this. So these examples are taken from the Open3D library. Again, it's a really good library to see how to work with C++, with real good C++. So we have the image library that we will see this really soon, but it's basically a type of geometry on 2D. Then they also define 3D entities. So this is wrong, so this shouldn't be here. But for example, you have a mesh base that's going to be a 3D entity. You have a point cloud that is also going to be a 3D entity. And then you have also voxel grid that we saw an example on previous lecture that is going to be a 3D entity. So this is basically some examples on classes. So you also know that people in our field does use this, and it's really important. And as to finish the lecture, so as a small example, this is the abstraction mechanism you should drive your mind when you think in classes. So we have the real world entity that is going to be an image. In this case, it's going to be an image that has 512 columns and 512 rows. The idea is you want to create an abstraction that represents closely with the real world entity this image. And then basically one thing you can think, so this is pseudocode, so this is not real. You want to define the number of rows, that's going to be integer, the number of columns, and then the number of channels. So if this is an RGB image, then this will be 3. And then you will have the data, that is basically all the data in the image. That's going to be, you can put it as a vector of bytes. So each pixel will store 1 byte for the 3 channels. So you will have all this information in 1 vector. So this is really common to do with images. And then you will like to use this abstraction in a way your program shows the intention of what you want to do with the image. So for example, you want to create a Linux picture object that is an instance of this type image, and then you want to do, okay, go and search the Linux PNG file. And then for example, I want to draw to screen, and for example, to visualize the image, and also for example, with this picture, I want to convert it from grayscale. So let's say you have an RGB image and then you want to compress everything into 1 channel and convert it to grayscale. So this is this is a wish. So you have an image and then you want programs to model these real world entities with abstractions, and then you want to use it this way. So let's see if we can more or less do this. So this is one possible realization of the image class, again taken from Open3D. So in this case, you will have a width and a height, that is basically the rows and the columns. You will also have the number of channels and a vector with this type. This is basically 1 byte, so this is 8 bits, and this is going to be the buffer with all the image information. So this is how these people solve, and it's really common to do it like this. So these are all the private members of your class, of your new type called image. And this is the implementation. Actually, this is not the implementation, the definition of some functions that you might want to use with this particular new type. So one, for example, could be clear. So you want to completely clear everything that is on this image. You also might want to do is empty. So you have an image type, and then you wonder if this image is empty. And then this is going to give you an abstraction. So it's really, if you do Linux pic.is empty, and this gives you a Boolean variable, then you can really ask if this is empty, and then you can express the intention of the program really easily. Then, for example, you want to flip horizontal, do a horizontal flip on the image, and then return this new image. And then, for example, you might want to filter this image out, and also this is another member function you might want to use. And lastly, for example, you want to allocate memory. So we saw that it's really good idea to reserve memory on vector buffers. So whenever you create a new image, maybe you want to allocate memory. So the idea is, did we achieve this goal? So we have a real world entity, and then we want to convert this real world, represent this entity with an abstraction. And then this is basically what we have. After defining all these steps on the image class, then this is how we would use it. And let's see if more or less like we reach the goal. So I'm creating an image. So this is real code actually, so you can build it and it will work. An image type, this is the name of the variable, and then I will create it from this particular PNG file. Then, for example, I want to create a new image that basically this auto replace the image type. And then I want the same Linux picture but flipped. So I can call this function and I will get the flipped image. And then, for example, I want to filter this Linux image. And then I will call this filter. And then, for example, I will use this type of filter that is also defined on the image class. And then I will get the filtered image. So if you try to read this program, it express really well the intention of what you want to do. So it's basically plain English. So you're really, so this is really a really good model of the real world entities using abstraction mechanisms. For example, if the filtered Linux is empty, so let's say that there was an error while filtering, I want to print an error and couldn't filter image. So it's really, really plain English, right? So basically the idea is to represent this entity with an abstraction. And that's basically it for now. So that's the quick overview of classes, right? We will see much more starting from next week on, but I want to start like injecting you ideas on your little minds. Must watch for this week. So before you get to do the homework, you need to watch this introduction. So it's a 5 minutes introduction of Bag of Visual Words. So you have no excuses for not watching it. It's only 5 minutes. The homework number 5 will be out soon. You still need to submit homework number 3 and number 4. So make sure you catch up with the homeworks. And also there will be an OpenCV tutorial because you also need to use OpenCV for this homework. So a lot of things happening with this homework. So the lecture wasn't heavy on concepts, but you will have to do a lot for your homeworks. And actually the homework is really easy. So the solution can be providing, again, 20 lines of code, and then you have the full solution, but you need to know everything on all the concepts involved. As a recommendation, you can do this feature descriptor video. So Cyrill has a lot of videos on SIFT and visual feature descriptor. So this is one of them. If it happens that you have no idea what a SIFT descriptor is, then you probably want to watch this video before getting to do the homeworks. But I guess that most of you already are familiar with the idea, or at least know where to find information. The references, and it's also an outline for this lecture, is the utility library, the error handling that we skip because of times constraint, and also the input-output library, plus the file system library, and lastly, classes. So classes is going to be the topic that we will discuss through the rest of the 4 lectures we have, and it's really important that you get to know how to model all these ideas. That's basically it from my side. If you have any question, you can write in the chat, or we can discuss it offline through Discord.